So here's a review of the flip-flop chip. So to start things off, let's try to understand what each of these variables here mean. So first of all, D stands for data. This data can either be ones or zeros. So it can be, ones, zeros, high, low, VCC, or ground. In reality, these are all just different variations of ones and zeros. Of course, we're dealing in binary. That's the chips we'll be using with throughout the entire year. So next thing is clock. So this is interesting. The clock will always be denoted by this little triangle here in a chip. And basically the way a clock works is through oscillations. So what do I mean by this? First of all, you need to understand that CLK stands for clock. And if we were to create a little example of oscillations, say this start is 0 and the top is 1. As you oscillate, meaning you go up and down, this value here, or rather I'll highlight in yellow, is 0, and this value here is 1. There's no power here, and there's power here. What's really dandy about using a clock in these chips is that you can create a very basic system of memory and recall through using either rising edges or falling edges. What do I mean by this? A better way to understand this would be to create a table. So now that we have a table, we can start filling it out. But first, I want to clarify what these variables are. So again, this is data. This is the clock. This is the output, Q, and not Q would just be the inverse output. So, when I mentioned you can have arbitrary memory, what I mean is you can manipulate the output of Q and not Q by setting the time at which Q will be shown. Q is based off data. So, for example, here I'm going to use this notation of a sign going upwards. And this denotes a rising edge. So what I'm saying is, back at this example here, I want Q to be output of D only in these rising edges. Only at this rising edge, because this right here is a falling edge. If we wanted to record, a falling edge, the notation would instead be a sign going downwards. So let's continue on with the graph. Now that we know we're only going to be looking at the outputs during the rising edge, we can take a look at the possible values of data. So data, of course, is just binary, so ones and zeros, or zeros and ones. It can only be 0 or 1. So, in this example here, assuming that the clock is on its rising edge, we look at data, and we know that the output of Q must be equal to data. The data in is 0, so Q would be 0, and the subsequent inverse of inverse of 0 would be 1. So then once again, we say, okay, so there's a rising edge, perfect. So that means I want to look at what the input of data is, and then put it onto Q and not Q. So what would be Q? It would be 1. The inverse of 1 would be 0. So effectively what we have here is a very rudimentary memory system. And if you still don't understand yet, which is a little bit confusing, I'm going to go make a oscillation table for you to see. This waveform to check with, let's take a look. So since previously in the graph we said that we're only going to be looking at the output when the clock has a rising edge, aka this, we are only going to be taking a look at these sections because these are both rising edges. So let's create a little line to see where they end up. So right here, we see that there's a rising edge here. So we're going to take a look at data. Data at this point here is a 1. So that means Q, the output, will be 1, or it'll start to be 1. And then, despite data changing, again, we're only looking at the rising edges. So we'll take a look at this part here. This is the second rising edge, or the second part we'll look at. So here, we see that data has now turned into 0. So at this point, we're going to make it a 0. So this is essentially a very rudimentary version of memory because, for example, in the space between these two rising edges, the output remembers that it's 1. And don't get mistaken that it literally remembers. It's just kind of a way of understanding it. It's not really remembering as in like technology or some sort of like really complex computer. It's just remembering based off the last output and the output next to it. So that's why we call it a basic memory. And I think that's really kind of cool.